Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, note, our lesson today will see the last of the revision work that we have been actually working on with the topics we've covered so far. So today we will look at the last of the revision activities, of which you will be assigned to complete those later on in the lesson. But before we go on to those last lot of revision activities, I would like us to make correction to the revision activities that you were assigned to complete in the last lesson. So if you look at those exercises now, and what I'm going to do is I'm going to get a couple of students to actually answer or give the answers to those questions, and then we will check the answers together from the monitor or on the monitor. There are some questions from yesterday or from the last lesson that will require you to do some calculations. So for those questions, those students who will be assigned to do those questions will need to come up to the front to actually show how they've got the answers and also to explain to the class. So let's check now with those activities that you were supposed to have completed for your revision work yesterday. Okay, the first of the activity was you had 3 maps of Australia. And those 3 maps of Australia, they showed the position of Australia 90 million years ago. The second map showed the position of Australia 45 million years ago. And the third map showed the position of Australia now or today. The question read, describe the changing position of Australia on each of the map that is given. There are 3 maps. You look at the map and then look at those 3 maps and explain the change in the position of Australia on each of those 3 maps given. Moses, you are going to give us the answer to the first question. Pass the microphone down. And the rest of you, you're going to check and make your corrections for that activity. The question again, describe the changing position of Australia on each of those maps given.
Australia is moving slowly away from Antarctica.
Okay, that's for generally for 3 of them. Would you like to actually explain for each map, perhaps how far apart according to the information that is presented? Moses, did you look at each map or you worked on generally?
Generally.
Okay, so Moses gave the answer generally. According to what he is seen there, he is saying that Australia has actually moved away from Antarctica and it is moving in the north direction. Did anyone actually do for each of those maps a description rather than a general? If you had a general description, that is also correct. But according to our question, we wanted to look at each map rather than all of it together. Silo, give us the answer to that particular question for each of those maps.
Mass. Australia and Antarctica were one landmass 90 million years ago.
Okay, wait, we'll check that one. We'll check that one. Silo says Australia and Antarctica were one landmass 90 million years ago. Check. No? Okay, that correction will have to be made. Check. 90 million years ago, they were not connected, they were not one landmass. So we cannot say they were one landmass. Anyone else besides Silo would like to give your answer for each of the map? Generally, it is correct to say that Australia was moving to the north direction away from Antarctica. Let's look at each map as stated by the question. Marian, your answer for each of those maps, describing the changing position of Australia.
90 million years ago, Australia drifted 2 degrees north, and 45 million years ago, it drifted 15 degrees north away from Antarctica, and today it drifted about 30 degrees north.
Okay, we'll check that information according to what Marian has given. About 2 degrees to the north, 90 million years ago. We happy with that approximate degree that she's given for how far it has moved? Yes, definitely. Okay, let's look at the second one, 45 million years ago. We're looking at 70 degrees here. This is about 50 degrees. But if we're looking at this point here and that point, we are looking at approximately about how many degrees? 15? You check. We happy with approximately about 15 degrees? Okay, good. And finally, today we are looking at Australia being about, this is 70 degrees, we check. This is 60, this is 50. So we are going 10, 20, and about 30, yeah? About 30 degrees approximately. Okay, so that is exactly what I wanted you to also look at in terms of giving the description of how Australia has actually shifted from each of the maps. You had the information to use on the lines of latitude, and if you had used that, your explanation will be similar to what Marian has given. Ovio, can you also give us the answer? Is your answer the same as what Moses has given or Marian? What Moses has given generally? Okay, maybe let's see a show of hands for those students who have given their answers generally. Just one answer to say that Australia moved north. Okay, okay. Hands up those students who've given their answer similar to what Marian has given. Okay, there's about 3, 4 students. And the rest of you, Gibbest, what answer did you come up with for that question? Then you didn't put your hand up. Okay, so hands up again, those students who have given the answer similar to what Moses has given. Okay, and Marian. Okay, so that basically maybe covers most of us. We'll check. Gao, you didn't have your hand put up. Your answer for that question. Same as Moses. Okay, so for most of you, maybe your answers would be similar to what Moses has given or Marian has given. We'll check on what is presented from the monitor here, and let's check to see our answer, possible answer that we could have given also. 90 million years ago, Australia was very close to Antarctica. If you look at the location of Hobart, which is that island just to the south of Australia, note that it is about 70 degrees to the south. Had you given a description, a detailed description, you might have included that information. 45 million years ago, Australia moved further north. Hobart now, if you look at its location in comparison, it is between 60 degrees south and 50 degrees south. Finally, today or now, if you look at the location of Hobart, it is about 45 degrees to the south. So what this is actually telling us is definitely Australia did drift away or moved away from Antarctica. Okay, you check and you make your corrections for that particular question. Second question, you are now supposed to calculate using that same information how far apart or how far Australia has drifted away from Antarctica in the last 45 million years. The last 45 million years, how far has Australia drifted away from Antarctica? Patrick. Okay, Patrick, do you need to do your calculation on the board to show how you got your answer? Okay, Patrick is going to only explain how he's got his answer, and the rest of us, we are going to double check on that work. The question again, calculate how far Australia has drifted away from Antarctica in the last 45 million years.
My answer was 2,200 kilometers.
Okay, his answer is 2,200 kilometers. Would you like to explain how you got your answer? Okay, explain why you are putting up those 1.2, where it's coming from, and etc.
The distance I got from the measurement of the roller Antarctica in Australia was 1.2 centimeters. And I got 1.2 centimeters and times it
Patrick, sorry, turn around, face the class.
by 1,200 and got 2,200 kilometers.
Okay, thank you, Patrick. We'll check on what he's got here, and let's check if most of you have got the same answer. First of all, that 1.2 is coming from the scale, according to Patrick. Is that right? Patrick? 1.2 from the scale? Okay, so Patrick is telling us that 1.2, according to the line scale, is equivalent to 1,200 kilometers. His X here, he's trying to find in centimeters, of which he's not supposed to. He's supposed to find the answer in kilometers to tell us how far Australia is actually, or has actually moved 45 million years ago. So therefore, if we had to double check on his calculations here, we need to do some corrections. So we will do the corrections together. If you measured according to how I wanted you to actually measure yesterday, and that was to look at from the closest point of Antarctica to the mainland, not so much of this particular island, we decided to leave that out. So if we measure from here to the mainland, the approximate distance, and that's supposed to be for 45 million years ago, would be approximately 1.8, yes. So that 1.8 is the distance that we would have actually got if we measured 45 million years ago from Antarctica to Australian continent. We are trying to find out by how far apart Australia has actually shifted or moved. So therefore, in order for us to find that, we already know the scale. So can we all now very quickly use our calculators? In order for us to find this, it will be x, which is equals to 1.8 multiplied by 1,200 divided by 1.2. And what will the distance in kilometer be? 1,000? We all happy it's 1,800? 1,800. We check. Do you all have 1,800? Christopher is not happy with that answer. You happy with that answer? Okay. So what we are saying now is for this particular question is that Australia has actually drifted, that's 45 million years ago, drifted about 1,800 kilometers away from Antarctica. We all happy with that answer? No? Yes? Okay, we can check the working out. Okay, we had 1.8 here on the board. The distance according to the information from A to B is 1.7 centimeters. Okay, maybe we will use about the same 1.8, 1.7. Then we have the distance between A to C, which it is needed also for our calculation so that we can look at approximately how far the drift has actually taken place. Our answer that we have got here, this answer here, is supposed to be to show us how far apart, 45 million years from today, Australia has drifted or moved. Okay, so we have 1.8, which is the distance we've calculated in centimeters. The scale is 1.2 is to 1,200 kilometers. 1.2 centimeters is 1.2 centimeters, is equivalent to 1,200 kilometers. We found the distance in centimeter, which is 1.8, and we've multiplied using the scale to come up with the distance as 1,800 kilometers. We all happy with the answer? Okay, good. Then we'll move on. The next part to that question now is to look at approximately how far does Australia move every 100 years? How far does Australia move every 100 years? Catherine, your answer, and also to explain to the class how you got your answer. The question again, approximately how far does Australia move every 100 years?
How I got my answer. 45 million years is to 1,800 kilometers from the first working out. I divided it by 450,000, and I came up with 0.004 kilometers. So yeah.
We're not very confident with this one, so we will check. Okay, we're looking at trying to find out approximately how far will Australia have moved every 100 years. We have this information here. This information here tells us that 45 million years ago to today, this is how far Australia has actually drifted, 1,800 kilometers. Okay, now what she's done here in her calculations is actually correct to come up with our answer. 45 million years ago, the distance Australia has actually moved from Antarctica is 1,800 kilometers. We want to find out for how many, in terms of how many kilometers Australia would move every 100 years. So therefore, we know the year, 100 years. We don't know how many kilometers, but we know for sure 45 million years it will take 1,800 kilometers. We know 100 of years or 100 years, but we don't know how many kilometers Australia would move every 100 years. So we do the same calculation like what we've done here for the scale. In order for us to find this, we will go x will be 100. I'll repeat that. In order for us to find our answer in kilometers, we go 45, multiply that by, no, hang on. We're not supposed to multiply this by, we're supposed to have the answer kilometers, so 1,800 kilometers divided by 45 million years. Okay, so it's 45 million years, so we'll make the correction here. So let's remove that 45 million years. We have the distance here in kilometers, 1,800 kilometers divided by 45 million. So for million, it will be 6 zeros, right? 1, 2, 3, 4, 5, 6. Okay, and this is millions of years. And that's not all. We'll need to multiply that by 100 because we want to find out for every 100 years how many kilometers Australia would have moved. Okay, so when we do our calculations, maybe for convenience sake and to make it easy for us, let's change these kilometers to centimeters. Let's change these kilometers to centimeters. So it will be multiplied by 100,000. So it will be 1,800 plus 100,000. Not plus, but times 100,000. That will give us how many more zeros? 5. 1, 2, 3, 4, 5. Is it 5 more zeros or 6 zeros? 5. Okay, we're multiplying by 100,000 to get that in centimeters instead of kilometers, so it will be easy for us to work with. We have 45 million years here, 45 million, 6 zeros, 1, 2, 3, 4, 5, and 6, and we multiply that by 100. So to make it easy, let's cancel out the zeros. Cancel out the zeros, right? Am I correct with my calculation of 18? I want to change these kilometers here to centimeters. Will I end up with this? We'll check. 1800 multiplied by 100,000. 5 more zeros added. 1, 2, 3, 4, 5. Okay, so that's okay. Multiply by 100. What should we end up with then? The answer will be 4. So we have 18000 over 45. When we do our divisions, 400 centimeters. Okay, that 400 centimeters, if we had to convert that into kilometers, it will be 0.004 kilometers, as given by what Catherine did when she did her calculation. So in other words, what we are saying is that Australia, for 100 years, actually moved 400 centimeters, or it moved 0.004 kilometers. The question wanted us to look at approximately how far apart does Australia move every 100 years. We know 45 million years, it moved 1,800 kilometers. 100 years, we don't know, and that's what we are calculating. So therefore, 1,800 kilometers over 45 million years, multiply that by 100 to find out for every 100 years how far it would move. And we do our calculations there, we would come up with 400 centimeters, which is equivalent to 0.004 kilometers. We happy with that answer? Yes? Okay, so here we are saying that it will take, or Australia would have shifted 0.004 kilometers every 100 years, or 400 centimeters every 100 years. And that's the answer to that question. I'd like to also do correction to the rest of the other activities. The second activity, now moving away from Australia, you have a table which summarizes the difference between the rocks of the ocean crust and the rocks of the continental crust. And all you had to do was to choose the correct word from each of the following pairs. Okay, the question reads, in comparison with the rocks of the crust beneath the oceans, the rock of the Earth's crust in the continents are lighter or heavier? We'll start from the front and we'll go around for the answer for that particular activity. Caleb, in comparison with the rocks of the crust beneath the ocean, the rock of the Earth's crust in the continents are lighter or heavier?
Lighter.
Stand up.
Lighter.
Okay, Caleb reckons that the rock of the Earth's crust in the continents are lighter. According to our table, the information from the table, it says continental crust, relatively light, 2.7 times water's weight. Oceanic crust, relatively heavy, 3.0 times water's weight. So we are going to go with the information from the table, and then we are going to accept Caleb's answer. So therefore, our answer should be lighter. Okay, good. Next one. In comparison with the rocks of the crust beneath the oceans, the rocks of the Earth's crust in the continents are thinner or thicker? Thick? Thicker? Okay, we're happy with that? Okay, that's correct. Let's move on to the next one. In comparison with the rocks of the crust beneath the ocean, the rocks of the Earth's crust in the continents are younger or older?
Older. Older.
Older. We check. We're all happy that it is older? Yes. Good. Give us the next one. Less varied or more varied?
More varied.
Okay, more varied is correct. And finally, little altered or much altered? Brendan?
Much altered.
Okay, it's much altered. So we check, make your corrections. The first one there should be lighter, thicker, older, more varied, much altered. Gideon, we're moving on. The next question. How does Australia's height compare with North America's height? Gideon, your answer for that question.
Is 2 times lower than North American.
Okay,
North America's height.
good. We're looking at Australia's height is 2 times lower, and that is correct. That should be the answer you should have. Gao, the next question. How does Australia's height compare with Asia's height? Question 2.
Australia's height is 3 times less than Asian's height.
Okay, very good. 3 times less or 3 times lower. And that should be our answer for that question. Francis, question 3. How does Antarctica's height compare with Australia's height?
Antarctica's height is 6 times higher than Australia's height.
Okay, Antarctica's height is 6 times higher, or we can say Australia's height is 6 times lower than Antarctica's. Okay, correct? Good. Let's move on. Question 4. On which continent is the world's highest point?
The world's highest point is the Asian continent.
Okay, good. Very good. We're looking at the Asian continent for our answer. Shelley, number 5. Which continent has the lowest, highest point?
The Australian continent.
Good. The Australian continent is correct. Question 6. Which continent has its highest point approximately 3 times the height of Australia's highest point?
The South American continent.
Okay, very good. South American continent. And finally, which continent has its highest point approximately 4 times the height of Australia's highest point?
The Asian continent.
Okay, good. The Asian continent. And that then concludes those activities that we were supposed to have done for our homework. Okay, you have a handout which has been distributed, of which the handout contains the last of the revision exercises, of which that I would like you to also do for your homework. You have one worksheet between 2 people. You can copy down your questions and then give the paper to the next person to make note of those questions. So the questions for your homework, number 1 to 5. What are plates? You defined. What causes plates to move? Number 3, what causes colliding plates to crumple and buckle? What evidence indicates that Europe and Africa separated from North and South America in the past? And what were the old land masses that have been called Pangaea, Laurasia, and Gondwana land? And that's what I'd like you to do for your homework. Okay, that brings us to the end of the lesson. Class, if you can stand up. Okay, to the pilot teachers, our keyword for lesson 33 is Pangaya. Good afternoon and thank you, students.